Welcome to my guide to taking your first steps with the Arduino Starter Kit. By the end of this video, I'll have shown you how to connect everything up, to get access to all the tools you're going to need, and to write your first lines of code. Let's get started by looking at the kit. Now, you might have a kit from Arduino, or you might have a kit from Elegoo. In either case, inside the box you're going to have an Uno R3 microcontroller that looks something like this. You might be wondering if it matters which brand of kit you have, and to answer that we can learn a bit more about the Arduino open source platform. The platform consists of three main parts. The first is hardware and covers the designs and specifications for the microcontrollers you have in the kit. The second is software, a standard language and set of commands for programming the hardware. And finally tools that let you write and compile code that the hardware can run. Because Arduino is an open standard, it means that any company can make their own compatible devices that run the software and use the tools. For this guide, it doesn't matter which brand you have, and we're just going to call it an Arduino from now on. Let's get started by setting up our development environment. We'll be using a web-based editor to program the Arduino. You can access it by going to create.arduino.cc. Select the web editor option, and you'll be asked to sign in or create an account. The editor loads in the browser, but before we can go any further, we'll need to first set up the Arduino agent. The agent is a piece of software that allows the editor to talk to the Arduino. You'll see an amber warning that explains how to do this. On Windows or Mac, your message will be slightly different. Click Learn More and follow the instructions shown to install the agent. I'm using a Chromebook, so I need to add the Arduino Create Chromebook extension. This extension is priced at $1 a month, but you might be offered a free trial. We click to add to Chrome, wait for the installation to complete, and then click Launch App to return back to the editor. With the agent installed, we can now see that the previous warning has been replaced with a device selector. Let's connect the Arduino via the USB cable. We can see the editor has detected the device, and we're now ready to start coding. I'm going to change the default theme that the Arduino editor uses. This is to make it a little easier on the eyes. You can do that in Preferences, and then I'm going to change from light theme to dark theme. This main area of the editor is where we code our sketches. Sketches are Arduino programs and are written in C++. The editor has created an empty sketch for us. We've got two buttons here, Verify and Save, Upload and Save. If we hit Upload and Save, the editor will compile our code and upload it to the Arduino. If we look at the device, you can see the RX and TX lights flash to show that the Arduino is receiving the data. Let's take a look at the sketch that the editor has generated for us. At the top of the sketch there is a slash and an asterisk. This block allows us to have a multi-line comment. When our sketch is compiled, anything inside this comment is ignored. You can also do a comment using 2 forward slashes. Comments are used by programmers to help them understand what's going on in their code. Below the comments we've got two functions, setup and loop. The setup function is run once when Arduino runs our sketch. We put code in here to set up the program. This could be things like setting the default state or telling the device which pins we want to output to. The loop function is called as soon as the setup function is complete. The loop function runs the code that's inside it, and then it is immediately rerun again, and so on. Before we edit the sketch any further, let's rename it. I'm going to call mine Hello. All of your saved sketches will appear in the sketchbook and are saved automatically to your Arduino account. To explain the fundamentals of writing a sketch, we're going to make a really simple start by just turning the built-in LED light on and off. First, in the setup function, we need to tell the Arduino the pins that we want to communicate with and how to do it. We do this using one of the built-in Arduino functions called pin mode. The pin mode function takes two parameters, the pin number and the mode that we want to use the pin in. We want to light up the LED on the Arduino, which is pin number 13. Arduino has a constant value we can use instead of the number 13, and it's called LED built-in. Since we want to output data to this pin to make it light up, we set the mode to output. Output is also a constant built into Arduino. With the built-in LED configured for output, we can start controlling it in the loop function. We'll use a built-in function called digital write. This tells Arduino to either power on or power off a pin. It also takes two parameters. The first is the pin number. Again, we'll use LED built in. The second is the power mode. We can use high to power on and low to power off. We'll start by powering on, so we'll use high. Next, we'll delay some time by using a built-in delay function. This takes one parameter, an amount of time in milliseconds. There are 1,000 milliseconds in a second, so a delay of 500 will be half a second. We'll power off the pin by doing another digital write. This time, we'll be passing low to ensure power is turned off. Finally, we'll delay again for another half a second. When our loop runs, we'll power on the built-in LED, then wait half a second, power off the built-in LED, and wait another half a second. The loop will be rerun, powering the LED back on again, and so on. Let's run it and see what happens. The editor will compile our sketch and send it to the Arduino. If we look at the Arduino, we can see that built-in LED is flashing on and off every half a second. If we change the amount of time we delay, we can control how fast the light flashes on and off. If we change it to 1 second, or if we change it to 1/10 of a second. Flashing the light on and off is okay, and it proves the Arduino works, but it's not really saying hello. Let's see if we can take this a step further by getting the Arduino to say hello using Morse code. Morse code is a way of encoding text using a sequence of dots and dashes. Each letter has its own sequence. By flashing the Arduino LED in the right way, we can make it spell out words. It's important in Morse code to make sure that the dots and dashes are sent using a fixed time unit. A dot will light the LED for 1 time unit. A dash will light the LED for 3 time units. We're going to send our Morse code letters at 15 words per minute, so this requires a time unit of 80 milliseconds. We'll create a constant to represent this. We'll need to write some functions to handle our dots and dashes. We'll create a function for dots and a function for dashes. A dot is sent by turning the light on for 1 time unit. So we'll power the pin on high, we'll wait a time unit, and then we'll power the pin off again. We also have to wait a time unit before writing another dot or dash. Sending a dash is similar to sending a dot, but this time we want to show the light for 3 time units instead of 1. We need 2 more functions to show spaces between letters and words. To show a space between a letter, we need to turn the light off for 3 time units. And to show a space between a word, we need to turn the light off for 7 time units. With our functions ready, we can now start writing out Morse code. Let's start with EH. This is 4 dots, and we can simply call our function 4 times. At the end of our letter, we need to make sure we include a letter space, and so on for the remaining letters in the word. At the end of our word, we need to include a word space. So when our loop code is run, we'll flash the light on and off to spell out hello using Morse code. Finally, we'll have a word space, and when the loop is rerun again, it will again spell out hello. Let's run it and see what happens. The lights are definitely flashing, and it looks like it could be Morse code. But we can tell for certain by using a Morse code app to decode the light. Here's a free app that I found on Google Play. I click to lock the phone's camera. I set the app to read 15 words per minute to match the time unit we set earlier. And we can see it begins to decode the letters one by one, and it correctly deciphers our repeated message. I hope this has helped you taking your first steps with the Arduino Starter Kit. We've only just scratched the surface, and there's a lot in the box. If you'd like to join me to continue learning more, then please check out the link in the description. Thanks for watching, and I'll see you soon.